All right. Good morning, sophomores. Today we're going to be learning how to calculate thermochemical equations. We're going to have a very brief introduction of what is thermochemistry, and we're going to use those chemical equations along with their heat energy value to understand how much energy is released or is absorbed for each of the substance in the chemical equations. But to understand this, let's have an introduction of what is thermochemistry. Thermochemistry is actually a course, believe it or not. It's a course that we study in college when we are in chemistry fields. It's going to be your fourth-year course in chemistry. So today we're just introducing it. When you go to college, you'll have a better understanding of it. But thermochemistry is the study of heat changes in a chemical reaction. You know that all chemical reactions have some type of changes of heat, either the heat energy is actually released or it is absorbed. We have talked about that a few months ago as well. Now, throughout this lesson or in these practice word problems, you're going to be seeing chemical equations similar to what we see here. And in that chemical equation, you're also going to be seeing your delta H. Now, that delta H can either be a positive or negative value. Now, we know that in a chemical reaction, the heat can be absorbed or it can be released. Remember, we talked about this a few months ago when we mentioned endothermic and exothermic reactions. If the heat energy is being absorbed, an example of that would be ice melting. If the heat energy is being released, an example of that would be fire in this case. Now, reminder, endothermic reactions is when the heat is absorbed, for example, an ice pack. And that's why it gets very cold. It's absorbing all of that heat. And when that heat energy is absorbed, the delta H value, the heat energy value, is positive. Now, in an exothermic reaction, the opposite, the heat is released, kind of like this explosion right here. And when that heat energy is released, the delta H value is actually a negative value. You need to know the difference. But it's pretty simple. In the chemical equation, when I give you the delta H, you will see a positive value. If it's positive value, you know that it's endothermic. You will see negative value. If it's negative value, then you know it is exothermic reaction. Okay, so here I give you two examples. What type of reactions are they? In the first one, the top one, this chemical equation, we see that the delta H is actually a negative 1625 kilojoules. The delta H is negative. So because it's negative, what type of reaction are we looking at? Are we looking at endothermic reactions or exothermic reactions? Well, because it's negative, we are looking at an exothermic reaction. So here we go, the exothermic reaction. Now in the second equation, the delta H is a positive value. And because it's a positive value, which means the heat is absorbed, it's going to be an endothermic reaction. All right, so delta H, what is delta H? It actually represents enthalpy. Enthalpy is pretty much the heat content of the system at constant pressure. What does that mean? That means the total amount of heat that was actually absorbed or released in a chemical reaction. So whenever a chemical reaction occurs, energy is either going to be absorbed or released, and that represents enthalpy or delta H. Now, your delta H unit is going to be representing with kilojoules. You have to be careful because in your word problems, if they are mentioning any other unit, either joules or calories, that means that you might have to convert it because delta H is always going to represent kilojoules. But if they're asking for values in calories, then you have to convert the kilojoules to calories, which you already know how to do because we worked on that last week. All right, so steps 4. So before we begin the practice problems, 3 simple steps. What is it that you have to do? In the word problem, I'm going to give you a chemical equation. Next to that chemical equation, I'm going to give you a delta H value. That delta H value is the enthalpy. And in the word problem, I will give you an initial value, the value that you're going to be working with along with the substance. So step number one, you have to convert. If they give you grams, you always have to make sure that your grams is in moles. How do I do that? You know how to do that already. Using your periodic table, you use the molar mass and you convert your gram substance to moles. Once they are in moles, then you take your mole value and you calculate that by or multiply that by the delta H that's in your chemical equation. Now you have to be careful because your chemical equations, there's a reason why we have those chemical equations there. In those chemical equations, we're going to have these coefficients or a number in front of each substance. The number is going to represent the amount of moles. So your delta H is going to be per moles. We'll see that in the exercises. And once you've multiplied it, the final answer after that multiplication will be in kilojoules. Let's look at the first example so that we can work on this together. All right, let's look at example number one. Example number one says, how many kilojoules of heat are released by 18 grams of glucose? So what are we looking at? We're looking at a chemical equation. Within that chemical equation, we also have delta H, negative 2808 kilojoules. In the word problem, they give us 18 grams of glucose, which is glucose. Well, glucose is right here. Keeping in mind that in this chemical equation, each substance has a coefficient or a number in front of it. In front of the glucose, I don't see anything, but that number is there. The number is going to be 1. Each of those numbers represent moles. So in glucose, you're looking at 1 mole. Why do I need to know that? Because you're going to have to set that up in your T-table. So we'll see that in a minute. 18 grams of glucose, the 18 grams of glucose I need to convert to moles. 18 grams converted to moles by using the molar mass, which is in my periodic table. So first step, take my 18 grams and I convert it to moles by using the molar mass. So C6H12O6 has a molar mass of 180 grams. 18 divided by 180 grams is 0.1 moles. Now that it is in moles, I take the 0.1 moles and I use the delta H, which is the kilojoules per the amount of moles in my substance. In this case, I have 1 mole in front, so it's this amount of kilojoules per 1 mole. So 0.1 moles, which is from the previous calculation. The delta H, I write that here, and my 1 mole is the amount of moles for the substance in that chemical equation. I have 1 mole because there's only one in front of the chemical equation. When I do the math, it's going to be negative 280.80 kilojoules. That's my final answer. All right, next example. For example number 2. How many joules of heat are produced if 144 grams of oxygen participate in the reaction above? Well, in this case, the reaction is below. The chemical equation has oxygen as a reactant, and I also have my delta H. I'm starting with 144 grams of oxygen, but I need to convert that to moles first. Using my periodic table, find the molar mass of O2. In this case, it's going to be 32 grams. So 144 grams converted to moles with the molar mass, and I get 4.5 moles. Those 4.5 moles, I then use that by multiplying it by the delta H per moles. I'm working with oxygen. In the chemical equation, I have 6 moles of oxygen. So making the T-table, it's going to be 4.5 moles, and I multiply that by the delta H per 6 moles of oxygen. And when I multiply and divide by 6, I get negative 2106 kilojoules. The word problem asks for joules. So that means that I am not finished yet. because my answer, I need to convert it to joules. So the kilojoules, I know that in 1,000 joules, I have 1 kilojoule. And when I convert, I get negative 2,106,000 joules. Or I can rewrite it in scientific notation. Both answers are correct with the correct unit within each of them. Example number 3. How many grams of the product are formed if 3,900 kilojoules are absorbed? Now, notice that in the first two examples that we just worked with, we either started with grams or we started with moles. But in this example, I'm starting with kilojoules. That means that I'm going backwards. So this is the same steps of example 1 and example 2, but backwards. So I'm starting with 3,900 kilojoules. And those 3,900 kilojoules, I use the delta H per the moles. In the word problem, it says how many grams of the product. For this specific equation, I only have one product. So that means I'm only working with this guy right here. So it's going to be delta H per 2 moles of the product. So when I write my T table, the kilojoules are upstairs, so downstairs, so that they cancel out, has to be the kilojoules. So downstairs, I'm going to write the delta H, and upstairs, I'm going to write the moles. Remember, it's per 2 moles because in my chemical equation, ferric oxide has 2 moles. Multiply 3,900 times 2, divided by 1625. The kilojoules cancel out, and I'm left over with 4.8 moles. Almost done. Now, if I go back to the word problem, they're asking for grams. I have moles. I have 4.8 moles of the ferric oxide. So that means I now have to change it to grams by using the molar mass from, again, the periodic table. So the 4.8 moles, I find the molar mass of Fe2O3, and I multiply that, and I'm going to end up with the grams. 766.08 grams Fe2O3. Again, where did I get the 159.6 grams? That's using my periodic table. I'm finding the molar mass of 2 irons and 3 oxygens. And that adds up to, or totals up to 159.6 grams. And the last example, it says, how much energy in calories? Now they're asking for calories. So far we've been working with kilojoules. So that means that we have to do some conversion eventually in this word problem. How much energy in calories is released if 7.8 moles CH4 reacted, or methane? The chemical equation has methane or CH4 as a reactant. I have my delta H, it's negative 891 kilojoules. Now, I start with 7.8 moles. I don't have to convert it using molar mass because it's already converted. I only convert using molar mass if in the word problem it started with grams. Automatically, it's already in moles, so I just go ahead and use my moles along with the delta H. Now, I have to look at the CH4, and I have to look at the coefficient that's in front of the CH4. Right now, it only has 1 mole. So when I make my T table, I start with 7.8 moles. I'm going to use the delta H, this negative 891 kilojoules per 1 mole. Now I'm not finished yet. I'm going to do one long T table because I know that when I multiply and I divide by 1 mole, these units cancel out. I'm going to end up with the answer in kilojoules. But I actually want the answer in calories. So I know that those kilojoules have to be converted to calories. Now, how do I convert that? Last week, I learned that in 1 calorie, I have 4.184 joules. So the kilojoules, I would have to convert it to joules, and then the joules convert it to calories. How do I do that? Well, I know that in 1,000 joules, there's 1 kilojoule. If I have kilojoules upstairs, I'm going to want kilojoules downstairs so that they cancel each other out. And I end up with joules upstairs. And then I know that in 1 calorie, there's 4.184 joules. So another T table, joules upstairs, 4.184 joules downstairs, and 1 calorie upstairs. How do I solve this long T table? I multiply all the numbers upstairs. 7.8 times negative 891 times 1,000 equals, or enter. And I divide that by 4.184. And it's going to give me a long answer. I can write that long answer, or I can change it to scientific notation. They're both correct answers, as long as they're rounded to the nearest hundred. And notice that the new units, it's no longer kilojoules because I converted it to little calories, lowercase c, calories. And the next question, is it an endothermic or exothermic reaction? How do I know that? Well, look at the delta H. The delta H is negative value. If it's a negative value, it's going to be an exothermic reaction. So this reaction in particular, it's an exothermic reaction. Now it's going to be your turn. You have the examples. You're going to read each of the word problems carefully. Notice that each word problem has its own equation and its own delta H. Answer those exercises in your notebook. Don't forget to round to the nearest hundred, and don't forget to submit. If you have any questions on how to solve this, you can also privately send me a message, and I'll try to respond as soon as possible. Good luck, guys.